Hello, everyone. Thanks for having me here. I hope you're enjoying the content so far. I'm Vaidik. I am a technology consultant. I primarily work with startups and growth stage companies. The way I define my job is that I help product and engineering teams deliver better software faster. Before this, I used to work as VP engineering at Blinket, a grocery retail company based out of India. My trust with microservices started about 8 years back in 2015 when I joined Blinket. I was a part of the team that was building the tech for delivering groceries to customers in 90 minutes. And somehow we found ourselves dealing with microservices to scale software development across many teams. Little did we know what we were getting into. You can probably guess that the end result was not as exciting as we liked it to be. And that's why I'm going to be talking about microservices today. So most of what I'm going to be talking about is experiences from my work at Blinket. In my last 2 years at Blinket, I started spending a lot of time with the question, how do we get our microservices right so that we get benefits of this architecture? We were in a mess and we wanted to get out of it desperately. Interestingly, when we looked around a bit, we found many companies that were in a similar boat. So to deal with these problems, I started to find the answer to how do we get microservices right? And most importantly, once we get them right, how do we maintain that state as we add more code and more components? The talk is about microservices maturity. So let's explore what that really means. Getting microservices architecture right. There's no one binary right or wrong answer to a question like this for any company, let alone all companies. The answer is the famous phrase, it depends. So microservices maturity to me is a measure of how far in the spectrum of getting microservices right are we. But what is right and how do we measure it? Let's look at the Microservice Promise as a starting point to answer that question. This is the definition of microservices architecture that I think most accurately defines microservices. Reliable applications broken down into a collection of smaller, loosely coupled services that can be independently developed, deployed, and scaled. The emphasis is on reliable services that are loosely coupled so that they enable teams to independently write code. That is, build new features, fix bugs, improve the code base itself, then deploy changes without the teams having to coordinate with each other and other teams, and then operate those services in production independently as well. And if you think about it, microservices is actually more of an organizational construct than a technical one. The technical interventions are, of course, there to support this organizational need, but still, microservices architecture is an organizational need. And if microservices are an organizational construct, then there should be a way for us to measure organizational efficiency and performance. So if we can measure organizational performance of teams working on microservices, that might help us understand the state of microservices and their effectiveness in our company better. How can we do that? Now, by now, you all have probably heard about DORA metrics many times over the past 5-6 years now. You're probably using it as well in your company. What's the objective measure of the success of microservices architecture? If microservices were to help your team ship better software faster, then DORA metrics can be used as a proxy to understand the impact of microservices and how your team ships software. Let's see what DORA metrics say when your microservices architecture is not helping your organization. And to explore that, I'm going to start with a short case study of Blinket, the company where I used to work before I started consulting. Blinket started up in 2013 as a hyper-local grocery marketplace delivering orders in 90 minutes. It was a grocery retail app where customers could find nearest grocery store to buy groceries, and then we will deliver those groceries to you. We start with a very simple architecture, 3 simple application backends. One was to support the consumer-facing application, and the other 2 were the applications that were there for all internal operations like catalog management, logistics, order fulfillment, support, etc. The business was initially very simple, so this simple architecture worked really well. Everything was on AWS from day one. But as the business grew, as we solved more problems, especially as more people joined the team, it became hard for us to work across these applications. There were a lot of problems being worked upon in parallel by many teams. And so when more people started working on the same code bases, they started overstepping on each other's work. And eventually we started slowing down. As in a startup, often it just felt like that we are slowing down because of lack of manpower and bandwidth. And hence we hired more people. In fact, at one point of time, we acqui-hired a team and doubled up our engineering strength. And the problem just kept on getting worse. We thought that the obvious solution for us was to move to microservices so that teams could truly independently work. So that's what we did. We started breaking applications into microservices to enable teams to work independently. Every time we could see a new problem that could be independently worked by our team in a domain without dealing with the complexity and chaos of our existing code base, we would spin off a new microservice. And when we'd spin off a new microservice, teams would sort of look at the tech stack from scratch to sort of leave behind the legacy and the bad decisions that we had made. The idea was always to use the best tool for the job. And further, to make our teams truly autonomous, we felt it was important to give them end-to-end ownership of their systems, including infrastructure. So we wanted to make sure that every time somebody wants to try something new, wants to run a new experiment in product and tech, they should not get blocked because of an artificial or a real constraint. Artificial constraints like engineers not having access to provision infrastructure, and real constraints like not having the right training to be able to use certain tools and technologies. So we wanted to push the idea of developer and team autonomy as far as we could. We adopted you build it, you run it philosophy. And as a result of that, we started building dev tools that would facilitate this philosophy and enable our teams to be able to run as autonomously as possible, so that all this operations related to infrastructure and applications are simplified as much as possible. So for example, configuration management was key to allow developers to ship software changes and configurations quickly and repeatedly. So we trained all of our engineers on how to use Ansible to manage their applications and their configurations. And it did not stop there. So we further extended our usage of Ansible. We built tools on top to make it easy for them to use Ansible itself to provision infrastructure, to use their existing application deployment playbooks to set up infrastructure auto-scaling, configure auto-scaling policies, etc. And the DevOps teams were there for governance, for providing guidance, for building these tools and maintaining these tools so that developers could really own the end-to-end life cycle of their applications. I don't think platform engineering was a thing back in the day, but we were pretty close to that, at least according to the current definition of platform engineering. And I think this was a great place to be. We were pretty proud of what we did and the kind of behaviors we were able to build in our teams. And even the engineering teams really welcomed this fresh change that they were not used to. They were not really used to having this autonomy that this tooling and this philosophy provided to them. So we had a great run with our systems and processes for about a year and a half. But in early 2018, we realized that things had been going downhill for us. Teams were working independently on their microservices, deploying multiple times a day, but we were really shipping poor quality code that were leading to bugs and outages, frustrating customers, and even internal users and management. Our engineers were burning out as they were busy firefighting more than actually shipping value to customers. So our systems had become so complex, and they were only getting worse. As we had more code, the experience of working on the code base was becoming even more terrible. Look at those DORA indicators, right? Those are for Blinket. For an engineering team of about 60 engineers, we had a decently high deployment frequency, but also our lead time to ship features was extremely high, about 21 days. That's death for a startup. I don't have the CFR and MTTR numbers because we weren't really measuring them accurately back in the day. And quite honestly, we didn't even understand DORA back in the day. But if we were to look at the number of bugs reported per week as a proxy for quality, 120 bugs per week is an insanely high number when compared to our deployment frequency. Basically, the entire team was busy firefighting every day. And so the deployment frequency was high because most of those deployments were actually to put out the fires. Due to the time spent fixing bugs and fighting fires, we were actually slowing down and not able to ship enough value to customers. This is not what we had set out for. We're delivering changes faster, but we're also creating mess continuously with those changes. To me, that is not what a mature microservices architecture should be like. And that led to the obvious question, what's missing? I think the first obvious thing we realized that there was nobody in the entire engineering org that was worried about the evolving system and its architecture and what implication it has and what problems it was causing. While teams tried to do the right thing for the most part, they were worried only about their services and their boundaries. But somebody had to also make sure what happens across these boundaries and how these boundaries interact with each other. What did this lead to? Too many microservices, more than necessary. At one point of time, we had double the number of microservices than the number of engineers on the team. And this is a common problem that I've seen with so many teams that struggle with microservices. We had cyclic dependencies. We became a distributed monolith, and one that lost the essence of a fast-moving, high-performing engineering org that also meets quality standards. These services eventually became so hard to work with that most of the time our engineers were frustrated to work with those code bases. Deployments had to be coordinated. We had an insanely diverse tech stack. You name it, we had it. Sometimes we even had different technologies for the same purpose. This unnecessary diversity stopped us from achieving economies of scale because of lack of standards, common tooling, and most importantly, mastery over anything. Every tech stack required a unique way of thinking about continuous delivery, which made our journey a lot more painful. What else was wrong? Not enough guardrails for quality. I mean, we were writing tests, but those tests were not really adding as much value. The biggest question was, how are we going to ensure that the product built up of these smaller microservices is going to continue to work as expected when a change is pushed in one or more services in production? We had no clear strategy to test our microservices to provide that level of quality assurance. Quarter after quarter, we would take goals to increase test coverage, but none of that led to any meaningful outcome in terms of quality. And it was not just for tests. We were struggling with other initiatives as well, like improving observability, adopting SLOs, and improving code quality, which also indirectly contributed towards quality. Let's look at another case study briefly of a healthcare marketplace I consulted for earlier this year. Very similar story as compared to Blinket. This is an engineering team engineering team of about 60 engineers, working with over 90 microservices. High deployment frequency, but extremely high lead time, extremely high change failure rate. Outages were frequent. Resolving incidents could take over 2 days of time on average. Then we worked together to improve these numbers. We improved the lead time quite a lot. It's not ideal, but it's much better than before. We reduced the deployment frequency intentionally in the interim because we wanted to focus on improving quality. There were no automated tests, so we had to batch changes so that we can test the entire product before a one big release. Super painful, not ideal, but it was effective in the interim to reduce bugs, outages, and improve the change failure rate. And this allowed time for our engineers to focus on improving quality. So in parallel, we started a focused effort on writing automated test cases so that we can stop testing manually and stop gating releases like we used to. By now, I've spoken or consulted for over 20 companies on this problem since we faced the challenges with microservices at Blinket. There's about 8 years of a time frame. Every single company seems to be struggling in similar ways, not getting the benefits of microservices as they would like to. A lot of tech to run microservices has been built in the community, but not a lot has changed for almost a decade about how engineering teams are adopting microservices. And that needs to change. Reflecting on these experiences led me to some learnings that I want to share next. The first lesson, as engineering leaders, a lot of our job is to control entropy of the entire system. As the organization and teams grow bigger, we produce a lot more code and add more components to our systems. The growing of entropy is largely inevitable, but the rate of growth, I think, is under our control. Entropy inevitably will go out of control when everything is easy. It should be easy for our teams to do the right thing and not just do anything. For example, yes, microservices do enable us to choose different technologies for specific problems, but that does not mean that it is okay to do it all the time without a clear reason. Unfortunately, reason and logic becomes hard to scale. So what do? Make things harder, especially making technology choices. When you're small, you can make things harder by reasoning about everything, let's say with the head of engineering or the principal engineer or the staff engineer. But when you're growing and becoming a larger team, you cannot be in every conversation. So you have to use economic levers to control entropy so that when a person on the team decides to introduce more entropy, they understand that it is worth their effort. What could these levers look like? Baseline expectation, like consistent contracts, minimal expectations of different types of tests, architecture review with adjacent teams, etc. Lesson 2, there's no such thing as best practices that you must follow. In fact, I think best practices should probably be called recommended practices. We almost never achieved any of the goals where we wanted to fix a practice across all the services in the entire org. Anything like let's increase coverage to 80% or let's define SLOs for all the services were never achieved. In retrospect, I think we probably even didn't need all of those things because we didn't fully understand the value of those practices across the org. Maybe some people understood it, but not the entire org. And hence there was not enough commitment from our teams. For example, deciding to use infrastructure as code tools is great, but using them for every single component is probably not worth it, especially the pieces that don't change frequently. And that might be good enough, at least for the moment, right? And you can slowly expand coverage when your teams have more time on hand and when they've knocked off other higher priority items from the list. Lesson 3, DevOps practices that have a clear plan for adoption get adopted faster, especially when the plan is attached to outcomes. Case in point, the time when our teams decide to improve documentation. If you don't have a culture for documentation, you have to be careful about how you introduce it and how you change the culture. What problems are you trying to really solve? We went from saying we need to improve documentation everywhere to we need to improve documentation to help onboard engineers faster. Our teams felt that without that minimal documentation, onboarding new engineers is becoming a big problem. It was affecting the teams directly. The outcomes and the associate tasks were also clear enough, like every repo should have a README with a brief description, clear and well-tested setup instructions, recommended tooling for development, and clearly defined owners of every repo and every service. And so it got done without a lot of stress. We made really good progress there. At the other extreme was testing. There were several holes in our plans to get better at testing every time we attempted to get better at it. One big reason why we were not able to progress on testing was most engineers on our team didn't know what kind of tests were valuable for us. For example, unit versus functional testing was a constant debate and were not easily resolved at a team level. Lesson 4, every team, and by extension, the services and the code bases owned by them, could be dealing with completely different problems and might have different needs. And the solutions for those problems need to be looked at differently as well, or the prioritization of problems to solve can be different. I've often seen teams get stuck in objectives like standardization. And while standards are a great idea, I think standards and systems can also come in the way of moving fast. To what level should you standardize should depend on economies of scale you want to achieve, and not just doing things the same way, just because that's how it should be done. And often there could be something better to do than just driving standards. We found ourselves prioritizing instead of blindly following all the practices across all the services, at least unintentionally. The cost of paying off debt altogether was very high, but whatever felt like comes in the way of delivering value or was a big risk, there's somebody on the team pushing really hard for us to solve for it. And then those problems got solved because it mattered to somebody. Phrases like critical services became common in our conversation. And I've heard other teams use similar classification for criticality as well in my consulting experience. That means something, right? So new and better practices get adopted where there is the biggest bang for the buck, critical services instead of all the services. I'll talk more about critical services shortly. But having some prioritization framework helps convey the urgency and make progress. And progress is far more important than being perfect. Lesson 6, somebody once said that prioritization is nothing but risk mitigation. And this can't be more true in the case of paying off technical debt. That is, all the things that are wrong with your architecture. Fixing architecture and paying off technical debt essentially means that you're mitigating some kind of risk. It can be risk of slow releases, risk of quality, can be risk, security risk, it can be knowledge risk. So paying off technical debt, instead of making it a blanket statement, I think it needs to be looked at from the perspective of risk. Back to microservices maturity. I started working on building a microservices maturity model that would help us fix our architecture and scale that process, but also help us maintain it as we add more code and components to our architecture. If you've not seen a maturity model before, here's an example. This is a continuous delivery maturity model from the book Continuous Delivery by Dave Farley and Jez Humble. This is a great approach to define and articulate practices that teams should follow depending on their journey, because practices don't get adopted in one day. You move towards vision and there are intermediate steps. In this case, it is about continuous delivery maturity. This framework highlights the importance of different aspects of continuous delivery to turn the concept into execution. Each of those rows is an area that is important for practicing CD, and the columns from basic to expert are levels of maturity. So you start from left, and the expectation is that you're moving towards right on each of the rows, hence maturing your CD practice. An important call out in the framework is the first row, culture. So maturing in most engineering practices is not just about maturing how you use tools and technologies, but also your ways of working. With a framework like this, you can clearly define those intermediate steps and also use them as internal or external benchmarks. This was a good detection, and it made a lot of sense to me. But we couldn't really take this to our teams and expect them to use it because A, it was too high level, not prescriptive enough about practices in specific context. It had only recommended practices, real solutions were actually missing. And lastly, it is aspirational. Following engineering practices can become a goal in itself than delivering business value. The microservices maturity model as we built at Blinket was heavily inspired from the previous one, but had some important differences incorporating our learnings. Here's probably 1/6 of that maturity model that we built. The idea was to look at all the practices while building systems instead of just one practice like continuous delivery. Let's quickly look at what do we have here. On the left side, we have pillars in the first column, which are sort of like engineering practice areas. On the second column from left, we have something called areas within these pillars. This way, it is not as high level, gets to a little more details on what kind of practices do we need to see in these larger engineering practice areas. And then third column onwards from the left, we have levels of maturity, level 1 through level 4 being the more mature state. So structurally very similar to the previous maturity model. This is more of a zoomed in view of the previous slides with all the details on the pillars and the areas. The first row are the pillars and the second row are the areas within those pillars. The pillars are sort of like macro engineering practices, as I said, and the areas are more specific practices within the pillars. So this way it is not as high level as the previous maturity model and adds a little more detail. These are things that you can borrow from our maturity model, like we did from some other maturity models. But the key thing to understand here is that what you decide to put in your model has to be important for your business instead of focusing on everything. Remember, it's a journey. Progress matters, not perfection. So depending upon your business, industry, and journey, you can handpick practices and craft your maturity model that focuses on practices that are important for you today and the ones that are infinite games that you must start playing. So for example, maybe you're in an e-commerce business like Blinket. Things like ability to release fast, run many experiments in parallel without breaking customer experience is important. So you create focus on agility, releasability, experimentation, quality, and resilience. Maybe you're a fintech business. Then things like correctness, transactional guarantees, security, and compliance matter a lot more. If you're a B2B SaaS business, then maybe reliability with compliance is more important. Maybe cost is more important. So you factor that in your maturity model. Now, third column onwards, we have levels just like the continuous delivery maturity model. But the difference here is that they have two sub-columns in them. One is called expectation, and the other is called support at Grofers. Grofers was the former name of Blinket. I will come to what expectations means later, but for now, let's just read it like we read the previous maturity model. So for example, synthetic monitoring area under resilience pillar on level 2 says, the expectation is that synthetic monitoring to be used in production with alerting. And the adjacent support at Grofers column specifies the recommended way to meet that expectation. In this case, we suggest that services must implement a well-defined smoke suite with P1 test cases that can run in all environments and can be periodically run in production using Jenkins. So we do not just set expectation, but also prescribe how those expectations can be met. That's what helps make a maturity model more prescriptive than open-ended. When a team looks at this, they know where they have to go and how they can get there in Blinket's context. One of the key differences in our approach, which comes from our learnings, is that our maturity model is not aspirational. It's actually risk-driven. So we don't try to make our services and teams more mature just because they should become mature. It's not like a career growth plan. We get better because our business needs us to get better because of the reason that our business has grown. And this is where we factor in different kinds of risks in our assessment. So the levels in the columns are not the levels that you try to get to, but the levels are pre-decided for every service because that comes from the criticality of that service in an environment. This was one of the key learnings we implemented. We are not going to get better because we should get better. We will get better because we need to get better. And this is why we call the first subcolumn, one of the first subcolumns on the previous slide as expectations. A service at a level that is expected to follow certain practices. For example, we have an area called service resilience, under which a level 3 service is expected to have certain breakers implemented to avoid cascading failures, while a level 4 service must practice chaos engineering to continuously validate that failures don't lead to cascading failures. So if you're not a level 4 service, you don't need to practice chaos engineering. You are okay with just implementing circuit breakers, while a level 4 service must do both. The levels are pre-calculated on multiple parameters like frequency of code changes, number of active collaborators, if it is in the critical path to serving the customer, etc. And we try to mostly calculate the risk automatically and centrally to use a common logic and assign a level to every service, and then see which services are where in their microservices maturity journey. Once the levels are assigned, teams can self-assess and set their journey to get to the level of expectations as guided by the maturity model. This started to make a lot of sense to all of our teams. It was getting tied really well into our structure where microservices are owned by teams. And after teams did a few self-assessments for their services, it started to become clear to them as to what are the areas that they need to focus on depending on the nature of the service and their own journey. Right after, we had the first quarter where most teams organically arrived at the most relevant goals that match their team's reality with minimal handholding. And again, just prescribing is not enough. Teams today have to deal with so many decisions and so many different kinds of tools and technologies. There's so much of cognitive overload. Expecting everyone to make the best decision for everything they do is unjustified. This is where platform thinking comes in, clearly defining how can we help teams adopt various practices without spending a lot of time making decisions and reducing the cost of transformation by achieving economies of scale. So all the things that you see highlighted in red and yellow are in the support at Growers column. These are possible solutions that platform teams came up with that could potentially help the teams adopt practices easily. But these solutions are not productionized today. They're not available. So this way, platform teams got a clear roadmap of things that they needed to build. And of course, we made sure that we're not tied to these solutions. So this was more like an outcome roadmap for our platform teams. It also stopped a lot of debate of we should do this or we should do that. We now had a framework to accept or reject ideas and focus on platform execution. And I feel that is extremely important for platform teams because the impact of their work is usually not clearly visible, sometimes not even to themselves. An outcomes-driven framework like this can help keep the platform teams aligned with product engineering teams and the business. What about domain boundaries? That's a very important topic while talking about microservices. So blurry domain boundaries is probably one of the biggest reasons for poor developer experience, releasability, and maintainability in microservices. So absolutely, work towards figuring out the right boundaries. It's not possible to cover this topic in depth right now, but there's a lot of material out there in this topic. But one concern I do want to address is, how do we know when the existing boundaries stop to make sense? And how do we detect that event in the life cycle of an architecture? There is no easy answer for it, but there's one answer that I think works. It is periodic assessment of your microservices architecture. If your microservices follow what has been prescribed by your maturity model, but your release cycles are still slow, shipping new features requires touching many microservices, and production outages have ripple effects. I mean, these are some of the examples, but it is probably time to evaluate your domain boundaries. Remember, the microservices promise, reliable services, loosely coupled, which can be independently developed, deployed, and scaled. If you're losing that promise, something needs to change, and it is most likely domain boundaries and their ownership. There's no immediate feedback loop for things like this. You want to differentiate one-offs from trends. So following a cadence like quarterly cadence or 6 months or something like that, to review metrics like DORA, postmortems, and contributor activity from Git repos can help surface patterns. That's it, folks. I hope you enjoyed the session as much as I did presenting it. I'd love to take questions or hang out with you after. Thank you.